Muy buenos días, muy buenas tardes a todos los participantes en este webinar del día de hoy. Muchísimas gracias a todos los que nos siguen por la plataforma de Zoom y por la plataforma también de Facebook Live. Si me hacen el favor de darme el control para poder poner la presentación. Gracias. Muy bien, muchas gracias a todos. Les rogamos a todos nos ayuden, por favor, apagando su cámara y su micrófono para poder tener una mejor transmisión y para poder disfrutar mejor del del webinar del día de hoy. Tenemos el día de hoy una invitada muy especial. Tenemos a Jessica Kinman, quien ella es especialista en industria aeroespacial de defensa de Dassault Systems, que nos va a platicar acerca de los retos de la industria aeroespacial para OEMs y proveedores, el camino a la digitalización de la nueva normalidad. Nos gustaría, antes de pasar a la presentación con Jessica, también informarles que la próxima semana, el miércoles 7 de octubre a las 11:30 de la mañana, estaremos también con nuestro webinar de la semana, soluciones del código de red y calidad de energía eléctrica en la industria aeroespacial y sus impactos y beneficios económicos, a cargo del ingeniero Pablo Kotkoff, quien es director general de Kotkoff Electrical, ¿no? Tiene que ver con los temas de energía y soluciones de energía. Ahí tienen el registro, solución de energía en Eventbrite y para que y también el código QR para los que quieran, los que nos gusten registrarse de una vez pueden tomarlo de ahí desde ahora, ¿no? Bueno, platicar un poquito acerca de FEMIA. FEMIA es una asociación privada sin fines de lucro que agrupa a las principales empresas de la industria aeroespacial de México, que en manufactura, mantenimiento, diseño, ingeniería y otros servicios. Tenemos más de 120 miembros en 14 estados de México y estimamos que el 80% de las exportaciones aeroespaciales del país son causadas por nuestros miembros y prácticamente somos la contraparte privada en México de cualquier cosa que tenga que ver con la industria aeroespacial. Ahí tenemos algunos de nuestros miembros. Muy importantes todos. A todos les damos las gracias por ser parte y por participar en esta red de industria aeroespacial nacional en México. Bueno, también quisiera presentarles, aprovechar la oportunidad para presentarles a nuestro staff. Empezamos con las damas. Tenemos a Pamela Arellano, que por cierto están atendiendo el webinar junto con nosotros, ¿no? Tenemos a Pamela Arellano, quien es nuestra directora de operación. Mónica Vega, quien es directora de promoción. Tenemos a Mariana González, que es la gerente de gestión y membresía, y a Marta Ortuño, que es la asistente de dirección y administración del proyecto. Y después tenemos a Javier Hurtado, quien es nuestro director de desarrollo de proveedores, y a Enrique Maldonado, quien es nuestro gerente de proveeduría. Su servidor, Luis Liscano, presidente ejecutivo de la Federación Mexicana de la Industria Aeroespacial. Bueno, un poquito presentar a nuestra invitada del día de hoy, ¿verdad? Jessica Kinman. Ella es ingeniera mecánica del Instituto de Tecnología de Oregon. Tiene una licenciatura en Administración de Negocios y Operaciones y un MBA en la Universidad Estatal de Washington. Ella es directora senior de experiencias en soluciones industriales de Dassault Systems, especializada en los procesos de la industria aeroespacial y de defensa para ingeniería y manufactura. Tiene 15 años de experiencia en la industria de manufactura. Es responsable de liderar la estrategia comercial para la transformación digital en todo el mundo a múltiples OEMs y proveedores de la industria aeroespacial. Antes de colaborar en Dassault, ella estuvo 10 años en Boeing, donde dirigió el equipo de transformación del Second Century Enterprise System para el proyecto de gestión de operaciones de manufactura, mejor conocido como Manufacturing Operations Management de Boeing. Ocupó varios puestos en la planta de manufactura, desde electricista, líder de equipo, gerente de manufactura, para respaldar múltiples programas de desarrollo y de certificación eléctrica. Antes de Boeing, ocupó varios puestos en el centro de distribución de Opélica en Walmart, como gerente de operaciones responsable de administrar las operaciones de dry shipping y respaldar 200 tiendas del sureste. Y Jessica además es la vicepresidenta de Mujeres en Manufactura del estado de Washington y también es directora de la Junta Nacional de Mujeres de Manufactura de los Estados Unidos. Sin más, le paso yo el control y le doy la bienvenida a Jessica Kinman. Jessica, thank you very much. Les informo también que la presentación de Jessica será en inglés. Así es que vamos a cambiar ahora, vamos a pasar a inglés. Jessica, thank you very much. Welcome to FEMIA. It's a pleasure and an honor to have you here in this webinar, and you know we're very excited to have you here and to see about your presentation. So without further introduction, just webinar is all yours. Thank you, Jessica.
Thank you for having me. Share my screen here, and good morning, everyone. I'm going to show a quick video. I want you guys to kind of think about what the video is talking about and kind of touch on some of those words that mean something to you real quick.
As we go through engineering revolutions, collaboration and automation of multidisciplinary design becomes increasingly crucial. Integrating disparate tools, organizations, and processes enables you to develop innovative products with confidence. Co-design revolutionary aerospace programs on time, on target, on specification. By virtually collaborating in the design phase, any change can be caught early in the process to lower costs, reduce design time, and schedule impacts downstream. When programs stay on track, you can spend more time on innovation, improve quality ramp-up, and minimize risks, all while lowering upfront costs. Get ready to innovate with agility. Learn more about the processes in your solution.
Okay, so hopefully that got you guys a little excited about what we're going to talk. So I'm kind of targeting you guys are all in either some way connected to aerospace OEMs and the supply chain and the value network, somehow contributing to the aerospace and defense industry. I'm going to talk a bit about the path to new normal digitization. We know the aerospace industry took a hit this past year. So we'll talk about what we can kind of do to help with that. What are some steps we can put in place? What might be a few things or projects you have come up that you may can prioritize that'll help give you some benefits. And then how to utilize existing and new technologies. Everyone's kind of in a different place right now. Some companies are struggling more than others. That's perfectly okay with what's going on. So we'll talk about kind of those different categories and what you can do internally to help get over kind of this hump that we're in, and talk about some opportunities as companies and as people supporting those that you can look for in the industry to maybe increase revenues or grab additional opportunities. So we're going to talk about the industry first. So if we kind of go back to that video, think about the words that you heard there. There were words innovate, collaboration, engineering revolutions. We talked about integrating separate systems, organizations, and processes, lowering costs, reducing design time. What's really great about each of these words, this is something either that would work before COVID or after COVID. We're always looking at quality ramp up. A lot of people kind of spin that and say, well, what about production ramp up? With the industry, we've seen some decreases there, but there's no reason why we can't always look at how to improve the quality pieces within the product. So these are kind of things when you're looking at projects, when we're talking about what is something that helps in really any phase of the industry or what we go through. These are things that will always help a company. So with that in mind, we're going to kind of take a snapshot of the last year. And again, I want you guys to kind of think about in your minds what that last year has been to a lot of you, both from a professional and a personal level. So the first snapshot I want to go into is kind of what I hear when I talk to someone and I say, well, how has the last year been? There's references to the 737 crashes, having the 737 MAX grounded, impacting the supply chains there. There were other design issues and some of what we've seen with the Boeing Starliner that kind of got items put on hold. Obviously, COVID for us was documented around that early January timeframe, and then we kind of saw a ripple effect there. We saw workforce cuts in kind of our larger OEMs and some of our tier 1 suppliers, and then as tier 2 and tier 3, we've seen that trickle down. We saw travel halted. I know at least here in the US, I've been stuck. I support a lot worldwide, so it made stuff with me. I still can't travel to the EU right now. In May, I think we really started seeing a major impact in the industry where those work cuts got deeper. And then we also saw the airlines being hit. We saw the money problems where profits were being cut. And then as we're kind of moving on to September, we see those drops in overall deliveries in the industry that we support. And I kind of have COVID here across because, you know, that's been here the whole time. So looking at this, kind of summarizing this and looking at this, we have different segments within aerospace, which is another way to look at this. So if we take these and we kind of bucket it up, what we've seen is overall airframe OEMs, your Boeings, your Airbuses, your larger OEMs have took a big hit in the commercial space. Because of that, the aerospace suppliers are also taking that ripple effect, and they're taking that hit. There's not as much engines needed because a lot of the planes are sitting down. So our propulsion suppliers and network there are also, again, taking the hit. Travel reduction, our airlines and airports. But what we have seen is the defense and space segments are still doing quite well. Some of those are depending on how funding is. A lot of defense contracts and stuff are done previously, so they kind of have a fixed rate for the next of the year. And in the case of space, there's still a lot of projects and companies that have now been privately funded that are then kind of pushing forward with what they're doing that haven't been impacted. So as companies, keep that in mind. Several companies, so a few that I'm working around here, have been really focused on just airframe OEMs in the commercial space. So first off, think about how you can diversify your portfolio now and in the future, and take those advantages and opportunities of supporting different segments. So when one segment kind of goes down, the other may go up or may be more stable, and you have the ability to kind of shift your production to support that segment of it. So again, keep that in mind when we do the aerospace side. So I want to go back and talk about that year again in more of an innovative way, and what are major events that have happened over the last year that maybe some people didn't know about. Around that March timeframe, if any of you guys were supporting Boeing and Airbus, both the 737 line and the A320 line were producing over 50 units a month of those aircraft. I mean, that's a pretty high rate, and they were pumping those out. The supply chain started struggling with that at the end, but just the fact that we were pushing out that many aircraft with those OEMs, that's a really big milestone. Other areas, aviation, they're kind of a startup company. They debuted Alice, which is an all-electric aircraft. So we've seen a lot of these startup companies start coming in and tackling this electrification projects and start bringing in smaller aircraft. They're looking at some of those new technologies that are a little different than what that traditional OEM has had in the past. Many of you guys are familiar, SpaceX. They've been all over the news this last year. Their Falcon 9 did their launch. We're returning to Earth, coming back on the ship. They've launched 120 satellites for Starlink, getting into that high-speed broadband connectivity. Some of that has been used recently in the news. NASA, looking going forward, they just awarded new contracts last year to Blue Origin, SpaceX, and Dynetics to build spacecraft capable of taking people back to the moon. There's a few contracts that have come out for Mars exploration. Toward the end of December, supersonic, that was a big topic that then came in. They've reached some major milestones, both with Boom and NASA in their testing phasing, where we're going to start seeing some of those options come out to the market. The Boeing 777X, as much as it kind of had struggles with getting their flight testing and those engines going on, what's very unique about that GE 9X engine, there was 300 3D printed parts on that. So we are seeing that switch to how can we utilize additive and printing and new materials, both in commercial design as well as that space and defense segment. Getting a little later in this year, we saw the SpaceX Dragon go up. That was a big milestone for private spacecraft to reach the space station. So again, when I talk about that space segment, it's no longer just governments launching rockets, launching satellites. That private sector is coming in, and they are bringing new opportunities to where now we can push a little further. We started seeing additive parts be certified. Honeywell came on for a critical engine part that was certified for flight. We also had the Oklahoma City. They came out with one of the first metal pieces that's being tested over on the US Air Force side for engines. And then kind of looking a little ahead here, we're seeing a lot of contracts. We're seeing a lot of projects being driven through governments. The EU is a really big one on their legislation to reduce emissions. And they have these target dates where they're starting to collect data on which companies are really impacting overall emissions. And, you know, I think eventually we'll see kind of like a scorecard that if you're highly impacting, you're going to have to start providing a plan on how to reduce that impact on our environment. So you're starting to see these groups get together and everyone sign on these pacts on how can we reduce emissions to help the environment with that 2030, 2035, 2040 as kind of setting up that next wave. NASA, again, is also looking at launching more mapping. There's been big investments there. Again, SpaceX is in the news all there. More opportunities to tie in, both private, both government funded. So even though we've kind of had a slowdown this year, there's been a lot of innovative steps happen kind of behind the curtains this year that we kind of have to consider in the next few years so you don't get behind. So again, just even with everything going on, there are a lot of positive things to look at and a lot of new opportunities as a business to kind of step in that direction. So one thing I like to kind of think about in the whole crisis impact is shifting from growth to resilience and how to handle that shift, how to start planning for next year. As companies, what could you put in both your short-term and long-term planning that as you improve your company, you can use those benefits now as well as with those long-term targets. And then just to give an idea, just some local articles and numbers throwing around that you guys can look at for marketing. With the space side, we launched 250 new devices last year. Our satellites over orbits totaling about 2,000. And if you start digging into the plan for space, they want to launch another 20,000 over the next decade. That could be anywhere from custom satellites to more producing the same thing over and over. It could be different companies. Again, just some opportunities there. NASA's budget for 2020 was still $22 billion. That's a big number. Again, areas that you can tap into, projects you can get tied into. The space startup, $12 billion just this year alone so far. With the space companies, they're able to get private investments. And, you know, I've been in aerospace all my life. My dad was in aerospace. People are excited about just aerospace. They're excited about space. They're excited about being a part of something that could be different. So you see, again, a lot of investments kind of drive into those startups where that passion is driving a lot of this. Some other areas on the defense side, I pulled up the US budget that is currently being proposed for 2021. There was still $57 billion in there. They had it broken down into different fighters, into the tanker replacements, into helicopters, into the P-8s at Boeing. So these are all contracts that have already been signed through the governments or that they're already pitching for next year. So again, when you're looking at that marketing and keeping that, okay, kind of where are we going for 2021, keep space and defense segments in your vision and look at some of those opportunities where you're supporting as suppliers. Look at different governments. We've seen, you know, I've seen not only with the US, we've seen stuff with the EU, you know, looking into maybe what Mexico does. Again, just more opportunities to branch out your portfolio in those industries. So even though we took a hit, there are still some areas that are being very active right now. Okay, I'm gonna move into technology, so kind of switch a little bit. Now that we've kind of defined, here is the industry broken into segments. Here's a few opportunities. What does that mean? You know, what can we do? How can we do it? So to start with, PwC came out with kind of good surveys. I think this is the 5th one that they've done this year where they're reaching out to CFOs, they're reaching out to executives at many of aerospace companies. And they were asking them, what is their plan? I think the 5th survey that I pulled some of these numbers from was across 989 CFOs from 23 different countries to get an idea of, okay, it's the month of June. What are you planning for the next year? And a lot of these, you know, obviously they're looking at trying to reduce costs, improve revenues where they can. But growth in this tech investment was something I found kind of interesting, where nearly 1/3 of them are looking to tech-driven products and services. Obviously, there's a second wave a lot of people are worried about. I know at least here in the US, we have that Thanksgiving and Christmas holiday coming up. So several of the companies I'm working with are trying to put something in place that may be able to mitigate that. So when we're looking at solutions, we can look at solutions that may work to combat that type of situation. And we'll get into some of those. And then the remote working area. I know here in the US, Seattle is a ghost town. Microsoft, Google, all of our big customers and companies have basically allowed everyone to work from home the rest of the year. So keep that in mind. What type of technologies, what type of projects could be used while people are working at home, but also when they return back to work in the future. And then just confident of overall safe return. So with these categories in mind, we're going to talk about what are some steps you can take based on the data that we're seeing from some of the consulting agencies, based on areas where we see opportunity for investments, and go from there. So I'm going to call these secret steps. If you guys, you know, they talked about my background at Boeing. I did implementation for projects, for processes. I'm from the manufacturing floor. So hopefully, if you get anything out of this, remember these 3 topics and think about what you're doing at your company to handle this. The first one is process. People can have good processes and they can have bad processes. Before you jump to technologies, before you jump forward, you kind of want to take a step back and evaluate, is your process the right process? I've ran several workshops at Boeing. When we started going through processes, we had like a user interface within the system, and I asked them, well, why do you have this section in here? And they were like, well, in the past we had it because we had paper and we printed it off and that's what we used. And I came back and I was like, well, you guys don't have paper anymore. Why do you still have that there? And they had never thought to remove it and put something that was more valuable for them that day there. So again, think about your processes. Think about how you're integrating from an end-to-end perspective. I ran another workshop on, it was automating, it got into robotic programming, and we pulled the engineers that did the design, we pulled together the employees that did like the MCD data files, they created the robotic files, and then we pulled in the robotic operators. And we had conversations. We mapped out the end-to-end. So, okay, we have the design. From the design, here are your next steps. Here are your next steps. And we had each of them talk about what were challenges within their process that impact them. And, you know, one of the operators was like, well, I'm missing this information and I always have to go find it. So that took time from him being able to operate the robotics and the machine. So we went back and said, okay, if that was defined and put within the program, does that make your job easier? Yes, it makes it repeatable. It shortens the time to do the work. It may add a little bit more to the programmer, but at the end of the day, adding that little bit kind of leans out the process down for the operator. So again, think about, do you have the right processes? Right now is also a good opportunity when we're at max rate, when we're kicking out those 50 planes a month. It's very hard to take a step back and evaluate internally, are those processes good? So right now, if, you know, with things a little slower, A lot of companies are taking that time to evaluate inside and lean out things. These will also, by leaning out these processes, you're going to possibly reduce costs and reduce waste now. And that's something you get both in the short term and the long term. Okay, the second step here is architecture. A lot of people, okay, we've got the process, we lay that out, and then we dive straight to solutioning. I want to be able to click here. I want to be able to use this. I like this product. It's very important from a business perspective of understanding and agreeing on an enterprise architecture, because when you start band-aiding solutions, throwing them together, long term, if you don't set up that architecture, you're going to have rework and issues down the line. And sometimes those can be more costly to fix, or you're going to have to kind of give in because the system's restricted you. Then if you took the time to take a step back and say, this is where and how we want to set up the architecture, and then finding the right pieces, understanding the inputs and outputs to those from process, from data. Again, just really taking the time to document that and have someone own that. So then they can say, yes, this aligns with what we want to do now and long term, or no, it does not. And the third piece of this is systems. Obviously, there are lots of limitations with paper. There's different steps that people can go into. There are systems that are available that can just be plugged in that you'll see instant benefit in right away. And then there are other systems that's really changing a culture, going from traditional file-based systems where I have documents and everything lined up to a model-based system is going to be very different. So you have to think about how to establish that foundation. And if you're going to take that, digital transformation path, or that big change culturally from something like file-based to model-based, and then that goes back to having the architecture and the processes to support that. So again, 3 big categories to think of, and we're going to talk about a few examples in these to kind of get you going. If you haven't already, if you are, that's great. So with process, we'll start here. Traditionally, I see a lot of process that is sequential. You have to start with engineering. Engineering has to be completed before you move on to manufacturing planning. Now I have an M-bomb, then we go to production. So it's very start-stop between some of these processes. If you look at that, you kind of have this delta time frame here, right? That you can't start anything till you finish this. So this is how long it's going to take me to do this process. What if we looked at that a different way? If you go back and evaluate some of those processes, are there timings that you can do in parallel, or can you even pull some back where they start at the same time? Especially if you have kind of a solid manufacturing area, if you know your processes, you know your employees, your resources, you can, during the design phase, start really with the manufacturing and saying, okay, we want to design these parts. Here are the manufacturing requirements that we have today that could help with this, and take that into consideration when you start doing the engineering design. This, again, for a lot of people is a process change. It's also more collaboration between organizations than we have traditionally seen at most places. But we are starting to see this shift where, as the engineering data or conceptual data of a product is starting, we're bringing in manufacturing earlier within the process to eliminate rework and issues that are going to be found downline. By doing this, you then go from that delta with time 1 down to possibly shorter and shorter depending on what type of process that you can do. Okay. Oops, sorry. Another option here is I work with a lot of companies on, now that you have those processes, understanding the inputs and outputs of those. So this is kind of example of what I do with my customers, where we're looking at conceptual engineering, we're looking at detailed engineering, we're factoring in test and simulation, we've got our manufacturing, We have our execution, so we're actually doing the work down on the floor. If you're dealing with customers and you have that feedback of what we kind of call the passenger experience, that's something to consider, customer feedback. And then if you're doing services, that's also considered here. So think about, now that we have these processes, what are the inputs and outputs to each pieces of these? Which ones are owned by what organizations? And then once you kind of get that set in place, that's kind of your level one, then you can start thinking about where that data resides. Do you have the data or do you not have the data? I kind of like doing this with my customers, and I'll kind of give you an example here on what does that mean. So this one, I was working with several customers that do aero structures. So like a large assembly, if I took all those little processes and kind of smushed them together into one page, what are we looking at here? So if you look over here, this area kind of to the left here, this is focused on what we call conceptual studies. This is starting that conceptual engineering up front, where we're going to start doing a little bit of documentation, a little bit of modeling. We're going to start documenting requirements of the product. And then that moves over into the detailed engineering phase here. Within detailed engineering phase on these products, think about the multidiscipline engineering. We have system architecture, we have electrical, we have structured components. Also keeping in mind that as the engineering gets there, we need to understand our testing, our certification of that. And again, bringing in our supply chain, how we want to track material, how we can optimize that manufacturing, tying in those work instructions, what programs we need to support the shop floor, and then actual execution of that. Again, we're also bringing in this case some of these design for services if that is supported within your companies. And then over top that includes all of this is that change management structure. So again, think the large picture sometimes on from a process perspective, from that architecture perspective. Is this what your company does? And are you missing anything? In some cases, you know, some of the companies I worked with might not do something. Is there something they want to do? Maybe think about putting that into the long term and seeing what pieces that you can install within the foundation to support that. Okay, we're going to keep going here. So I want you to think of another name. So we talked about processes. We've talked about looking at that enterprise side of this. When I say simulation, what is the first thing that comes to mind? Think about it. Okay, now hold that thought, because then I'm going to give you a few examples and options, and then we're going to come back to this. So what can you simulate? How can you simulate? What are you simulating today? And what could you simulate within the future? So this is kind of my joke. Does this type of architecture look familiar? Usually when I first go into a customer, I have a million systems, there's data all over the place, I have multiple SharePoints, multiple Excel files, and the first thing I always tell them is, okay, do you have that documented somewhere? Like if I came in, can you show me what your architecture is? Some people can, some people can't, but having kind of that, again, the screenshot of the architecture then allows you to see where your information resides. And it goes back to identifying that. Do you have gaps, or is there something you're missing that you need, and understanding, okay, where do I start from here? So this is almost like a baseline of your as is. So those are good to have. So now we're going to talk about tying in the process with your current systems. And we're going to kind of take this step by step. It's a lot. So if any of you guys look at that enterprise view, it's a lot of information. So you guys have your requirements management somewhere, okay? Whether some people use doors, some people use cameos, some people have it in Excel files. The idea here is, where are you documenting your requirements? The next step of that is moving into the functional and the logical of a system. How should it work? What are those functions? What do we want it to do? and then pushing into the physical. The physical here, most people are going to understand this as your E-BOM. So again, this is focusing on that engineering perspective. Then we move into the manufacturing perspective, where now that we have the engineering, we kind of then have the structure of the manufacturing BOM. We also get into fabrication and assembly processes. This is where you'll find your work instructions for your employees, and then your resources. Are you documenting what types of equipment have? Who do you have? What are their skill levels? And then incorporating that within the process. How do you know who you need to hire or what skill sets? This kind of helps you with that as well. And what's really great about this structure is a lot of times you can reuse this for support engineering. So this is associated, a lot of people, the S-BOM is kind of the service BOMs. It's the same process. You still need to document the manufacturing process for service. You still need to give work instructions to the service employees. So the more you can reuse for these processes, the better. And then going back to that simulation question, could you simulate not only engineering? That's usually the first one I get. When I say simulation, the first thing is, oh, simulating in engineering, or did the parts work? Do they hit each other? What if you could then simulate different steps of this to optimize that? You could simulate, some of the behavior models. You could simulate engineering, manufacturing, operations management, down on the shop floor, service. So think about that part. And then at a high level, how are you managing your business? Do you have a common change management system? How do you manage collaboration? Collaboration is a really big one. I see a lot of areas of opportunity with, because most organizations keep data segregated by their organization. Like engineering has a SharePoint over here, manufacturing has a SharePoint over here, quality has their own. Nobody talks to each other, and they'll write up an issue here and send it, and the issue is being tracked in 2 or 3 different areas. Again, a big area that has opportunities to be improved on collaboration between all these organizations. And there's several processes to reference that, whether we look at non-conformance processes or engineering change management processes, certification, safety. There's lots of organizations that utilize data in each of these. If you guys have new initiatives, understanding how to tie this to model-based. So if you're in that process where, okay, we've been file-based, we're starting to get into 3D, we're starting to create traceability with this, that's kind of that second part. So here is where you'll then start tying in the requirements within a system or some type of technology directly to the engineering data. So then that way, when you change any of that data, oh, red flag, we need to go back and evaluate these other pieces. So if you tie in each of these, you have basically a models-based process systems engineering up front with design. You can tie that into the physical part. So say a physical part is not available anymore, we need to know what else is impacted. And then that also ties into the manufacturing. Let's say you got new equipment, or equipment broke down and they're going to get rid of that. Does that impact or change anything upstream that then needs to be considered to fix that solution? You also have your MOM, your MES system, whatever manufacturing system you may use in part of this that ties that in as well. And then overall, just model-based collaboration on, as you're working this, you have traceability from end to end. You're increasing the collaboration between all these processes. So again, creating first a foundation of pieces broken into those different processes, into different data, and then now tying all of those together in a way that's going to optimize any type of change, and then optimize that flow all the way from requirements down to manufacturing out to service. No one can handle this all at once. So I'm definitely not saying, boom, go do everything. But just think about what you can do today to create these foundations and then have this at the end. This also ties into, as you increase some of that simulation, you'll hear references to digital twins. I like to see a lot of the digital twin for design and digital twin for your manufacturing and operations, and then getting those kind of to work together to reuse that information to where you can verify items again before they go down to the shop floor. Okay, so if we go back to that question, when I said simulation, hopefully this is going to open you up to a little bit more. You can simulate requirements, you can simulate different types of design, you can simulate the additive printing process, we can simulate composite layups, we can simulate composite with robotics, you can even simulate human interactions, whether if it's in service, you can simulate those people and say, okay, on average, the person's 5'5". Can they reach this, or do I need a certain type of tooling to help them perform the work? You can simulate material and stock coming in, simulating that schedule. Scheduling is a big area that I'm actually shocked a lot of people don't have a process. They rely on Excel instead of kind of a simplified scheduling tool that optimizes the material, the people, and resources. That's something that you can kind of plug in any day, and it's helpful. So again, open-minded as to what you could simulate other than just the traditional engineering process, and how and what benefits can you get that to reduce waste, to reduce time, to optimize product going in and out. With all of us kind of taking a hit with the downsizing this year, again, this is just an example of if you had either something existing that does this, or if you had options to put in something that would benefit you both today as well as when rate comes back up. These are all things that could do that. So I do want to give a few examples here. I talked about the schedule. So the master production schedule is kind of a teaser. It's one of my favorite products that we do. We have a product called OEMs that does that production scheduling. So you can have all of this documented, and again, most people use Excel for that overall production schedule, which is great to document, but you don't really have that optimization of as things change, as either workers are reduced or workers are increased, or machines break down or machines come in. Tying in your material stock, what's available, what's late, what's coming in, what's here. Bringing in those pieces together where you can do these what if scenarios. In this case, we had a machine breakdown. You can quickly throw it in there, say this machine's broken down. How does that impact my schedule? What do I need to offset that? Am I still going to be able to hit schedule? These are types of simulation and what if scenarios you can run by taking it a step above the traditional Excel for production. Material shortages is another one. Whether you have a supplier that's running behind. With COVID, I've seen a lot of people impacted for raw material. So that could be an option here that you could simulate that this raw material stock is not available for another 2 or 3 weeks. What can we do? How can we react to that to get back on schedule? You can also tie this into shop floor dispatching. So down to work orders or pushing down to people, depending on what you have in place today. Again, if you're in the middle of looking at opportunities, this just is something that plugs in quite easily and pulls some of those key data pieces. You don't need all the data to have something like this. So if you only have parts of it, just optimizing some of those parts are going to give you an opportunity and better benefit today. A few other examples with simulating. With COVID, we had a lot of people, we work with a lot of airports and a lot of manufacturers that then have that separation with production. So let's say in a normal day, we have 9 stations and 9 workers. You can utilize simulation for the process today as you expand. Again, this is pretending like nothing happened this year. A lot of people have some of these manufacturing simulation processes that can be used at that point. If you have kind of an issue with COVID and you now have separation or you have some type of reduction in labor force, you can still use that setup that you have for production, but now you're just reducing the number of employees. You can put some type of parameter that says, okay, these employees have to be 6 feet apart. I just worked on some of that with one of our customers here in the US, where they wanted to make sure their employees stayed safe. We did that within our office. Actually, we used our own product in the Valisi office to simulate coming back at 25% and 50% with everyone's schedules to maintain that we could be safe to do that. So again, examples of how you can utilize any manufacturing simulation for non-COVID days where anyone can go in there and work, or how you can use the same tools, the same models, but then just reduce the number of people and resources to still optimize what you have today. And then I think lastly, one more, was getting people off paper. So I'll give one example of the manufacturing engineering process for work instructions. We have, with some people working from home, with some people going to digitization, being able to do those work instructions online. If you have 3D modeling, even easier, you can link the 3D modeling directly to the work instructions. Your manufacturing engineer can create those work instructions within a system, give all the detailed instructions to the operator, and then push that down to the floor. So now it's digitized. Depending on where you are in the process, it can be as simple as just pushing it to the floor. If you can add in data collection, if you can add in operator acceptance. Again, going back to that, here's a basic foundation and you want to add all these pieces on top of it. So again, just another option on how you could do that. So if you go back, just remember, we talked about processes. You would have to have a process in place in order to make this as efficient as possible, understanding the process that both the manufacturing engineer and the operator need in order to do their jobs. You would want to understand architecture. So what data inputs and outputs are needed to create these for each person, and then how that kind of goes down line. Can some of that be done in parallel? Can some of that be done at the same time? And then again, understanding what systems you have today that might be able to help you, or if you are looking for an investment, what's a system that makes sense to bring in to help you out today? So again, I know it's a lot of information, but hopefully it got you thinking of different opportunities that with older technologies, with newer technologies, whether you have funding today or whether it's later, that you can utilize to help your companies today.
Thank you very much, Jessica. Thank you for your presentation. It's very, very interesting about how simulation can help reduce cost and do things more efficient. Now we invite the audience to post their questions in the chat so that we can actually ask the questions to Jessica. We have the first one here. Could the master production schedule simulation be effective around the loss of workers by illness in the line production in a long term, considering a global situation like the COVID-19 pandemic?
Yes, so people are considered a resource regardless of what number you have and how detailed you want to be. You could do take that and factor in maybe a percentage of loss. Or you can even do simulations and what if scenarios with these 3 or 4 people didn't show up today. Do I need to adjust my schedule to react?
Excellent. Le recordamos también a la audiencia que pueden hacer sus preguntas en español y trataremos de traducirlas de la mejor forma posible. We're asking the audience that they can also post questions in Spanish so that and we'll try to translate for you, and then translate back again. So, si hay más preguntas. Ok. Ya nos quitaron entonces, ¿cómo se llama la presentación? Entonces ya estamos nosotros de regreso aquí. Uno de los temas que más salen frecuentemente con los temas de simulaciones, ¿qué tan apegado a la realidad es ya una vez que lo llevamos? One of the things that are frequently come more often in simulation is that how accurately you can model the actual situation, the actual reality. Could you elaborate a little bit more? Because, you know, people tend to think that sometimes simulations are away from reality. That's a common misconception.
Yeah, so I think there are different, I would say, processes with simulation. For the engineering side, you have a lot of data available. So if you're simulating clashing of parts, if you're simulating how that functional aspect of the design works, yes, that's pretty accurate. I've seen many customers that go to very, very close tolerancing with that. If you're simulating the manufacturing process, it's as good as the data that you put in. So if you don't put any data in, there's kind of a larger percentage for error. If you can put more in of these are the tools, these are the equipment, here's the layout I have, ultimately that's going to improve kind of that that range on how accurate it is. I've seen some of those very precise. I was on site at Boom Supersonic, and they were actually simulating, there was a opening that they had to put a ratchet in, and they were actually simulating the mechanic having enough room with the tool to go in order to get to that position. So I've seen some at a very detailed level.
Okay. Something else that we have here is that, can you elaborate a little bit more on the space? You know, you talk a little very thoroughly about the space opportunities in your presentation, but you know, how about the defense opportunities? You know, can you elaborate and tell a little bit about the defense opportunities?
Yeah, so defense opportunities are very similar. They come out contractual. A lot of Boeing defense contracts that are currently right now were already funded and approved at least a year or two prior. In most cases, the money has already been set aside to fund those. They may have like a partial contract, like what they did with the Boeing tanker is, okay, you can make the first 150, then we'll have a second contract that does another 200. So look for that they may not do a full contract up front, but the contract may be in separate sections. And then again, down at the product level, it's very similar. They need electrical equipment, they need components. Depending on which defense sector you have, there may be limitations. So for some US products, those have to be created in the US. For some of Mexico's products, those may have to be created within Mexico because of your IP. So that might be a good area as to with the Mexican defense contracts, or if it's something they do within the country, you guys might have a better opportunity to get because you're within that region. Exactly,
you know, and that comes along with the USMCA, especially with the intellectual property chapter of the USMCA. Okay, we have another question here. What's the implementation average time of this technology, this simulation technology in manufacturing, and what's the average time of training for the user?
Okay. I think the best advice I can give for that is the more prepared you are, the shorter time frame you're going to have. So when I say make sure you have good processes, make sure your architecture and your data is properly documented, it will shorten any implementation time as well as the training. I just had one of the master production scheduling solution I just showed. We did a implementation in 8 weeks with a customer that was basic functionality of scheduling at the work cell level. So it wasn't quite all the way down at the lower level, but it was several lines per work cell that was live in 8 weeks. There are small packages that you can roll out. Taking a large project and breaking it up into smaller pieces usually helps with that implementation learning curve. Also involving, I've done system implementations, involving those people when you're designing it is also going to limit training. Identifying a very strong, what I call a center of excellence, having subject matter experts in those organizations that are capable of training their teams and getting those involved is going to shorten that learning curve. The worst thing you can do is roll out a solution and say, here, everyone, figure it out. So the more prepared you are, think of it like a ripple. If 10 people understand it, then they can train 20 people. Then those 20 people can train 40 people. That's going to shorten the learning curve on any system implementation.
That's very good. I have another one here. Is it possible to simulate events in aftermarket events? You know, for instance, MRO?
Yes. We have, take a look. We have a keep them operating process that specializes in service and MRO. At the end of the day, the same simulations you can do for manufacturing. I need to go to the aircraft. I need to get in this part. I need to do this. It's the same technology for MRO. I need to remove this panel. I need to go in and pull this out. I need to fix it. It's the same type of process when you get down to the foundational pieces.
Excellent. Well, you know, time is actually running out. You know, we certainly would like to thank Jessica for your presentation. It has been very enlightening for many things, and I have a last question here. It says that if when the plan layout is developed, the plan layout is developed after the detail engineering, or?
So my recommendation is the earlier you can do the plant layout, the better. Because think about if you're doing composites. Are you going to do hand layup? Or are you going to use machine? That kind of impacts the decision on how and what you need for that design process. So the earlier, the better. We have some customers, before they even break ground on a greenfield, they've simulated the entire plant and how they want to set it up. So again, recommendation, the earlier, the better.
Well, then again, thank you, Jessica, for your help. We certainly, it was very, very interesting. And we look forward to continue collaborating with you in the future. También queremos recordarles, vamos a regresar un poquito a español, vamos a recordarles también que la próxima semana tenemos el webinar de soluciones del código red y calidad de la energía eléctrica. Ahí están también los datos y les pedimos por favor que nos sigan en nuestras redes sociales. Estamos en Facebook, estamos en Twitter, tenemos el canal de YouTube y estamos en LinkedIn. En Facebook tenemos, esto salió en Facebook Live, pueden consultar el webinar en Facebook Live y también hay, ¿cómo se llama? Una repetición de todo esto, o la grabación de todo esto también la subimos en YouTube, en el canal de YouTube de FEMIA, en FEMIA Channel. Entonces, los invitamos a que nos visiten en nuestras redes sociales y les agradecemos el favor de su atención. Jessica, thank you very much for your presentation. It was very, very interesting. We thank you, and we thank also Dassault Systems, the actual collaboration with us in this webinar. And a nuestro auditorio les agradecemos el favor de su atención y les deseamos que pasen un excelente día y por favor manténganse saludables y no se enfermen. Muchas gracias y nos vemos la semana entrante. Hasta luego.